The following lesson is made to provide you with just some key formulas that are going to be useful for you as you go through the ACT math test. It's not meant to be exhaustive, and we're not going to be deriving or even discussing the formulas at too great detail, but we simply want to provide you with the tools for now as an introduction to the math test before we delve more deeply into each of the sections of the math test for you to gain more familiarity with how to use them. The first important set of formulas you're going to need to know for this exam are the area formulas, and these are generally, for all of our four-sided figures, a variation of just base times height, where you're going to take the length of the base of a four-sided figure and multiply it by the height of the length of the height of that figure. And that's true for rectangles, as we see here, also for squares, where the base and the height just happen to be the same, but also for stranger shapes like rhombuses, where you're going to have the base as one of the sides within the height as a value that you can usually solve for within the problem. Same thing for more complicated shapes like trapezoids, where the height is also something that you can solve for, may be given to you. The thing with trapezoids is you're going to have two bases. So you're going to take the length of both bases and take the average of those. So you take the average of the bases, if there's more than one base, and multiply it times height. So it's going to be the first base times the second base divided by 2, or plus the second base divided by 2 times the height, and then you have your area for a trapezoid. Very similar here for triangles. You likely have already memorized this one. It's been drilled to you into your head in school, but if not, it's going to be half the shape of what a four-sided figure would be here. Imagine that you had another triangle of the exact same area as the triangle you're considering, and it was sort of like added to the right of this image here, for example. You can calculate the height. You're going to use the base, which would be the base of that entire four-sided shape, to get the area, but we only want half that area, not the total area. So the area for a triangle would be 1/2 base times height. The last area formula that you need to know, and it's sort of a tricky one, has nothing to do with base times height this time around, is the circle area formula. That one is going to be pi r squared, where r is going to be the radius of the circle, or the measurement of the distance between the center of the circle and the edge of a circle. It's represented by red already here in the image shown on your screen. So those are the big area formulas that you need to know. Something a little bit easier to keep in mind, but just a quick refresher just in case, is the perimeter formula. For any single figure, no matter how many sides, all you want to do is just add up the lengths of all the sides of that figure, and you have the perimeter. Now for circles, rather than a perimeter, we're going to be dealing with something called a circumference. And a circumference is going to be the length of what would have been here a line or a belt that you would wrap around into the circle that you're considering. So sort of like the length that would need to be so that wrapped around you get the circle. We call that the circumference of a circle. And you're just going to multiply 2 times pi times the radius of the circle. Again, what was represented in red here for this image, and you've got the circumference. Another important set of formulas here for circles is this one. They will expect you to know from the area or the circumference, which you've already seen, what the radius is going to be, for example, and then what the diameter is going to be. Given any one of those values, you should be able to figure out all the others very easily. Let's go ahead and say that they gave you the diameter for this circle and they told you that it was 10. Well, if the diameter is 10, then the radius will have to be 5, because 5 times 2 gives you 10. So given the diameter, we know our radius. And given the radius, then we know the area will be pi times r squared, or 5 squared, so 25 pi, and we should know our circumference. So that's just going to be 2 times pi times r. 2 times r, 2 times 5 will give you 10, and then we've just got 10 pi for our circumference. So really, any one of these values gives you the others. And that leads us to some solid geometry formulas here. So the volume of a parallelogram is something that you have probably been learning since elementary school, but just in case you've forgotten, it's been a really long time. It's going to be the measurement of the length of, the width, and the height of your parallelogram. You're going to multiply all those together, and you get your volume. For cylinders, what you're going to do is you're going to take the area of the base, basically. You're going to here have the area of a circle, pi r squared, and multiply that times the height of the entire cylinder. You can think of this as being you adding up all of these little areas of disks that stacked up together would create the volume of the circle, or sorry, of the cylinder, and where the height is just giving you sort of like the thickness of each of these disks, I guess I call them, that would create the area. But basically, it's just the formula for the area of the circle, or one of the bases here, times the height of the entire cylinder, and you've got the volume of the cylinder. Another very important thing here is the parallel line system. A very easy way to remember this without having to remember all those complicated terms that you probably learned in school is that the alternate ones are going to be the same. So the alternate exterior here, for example, D and F are going to be the same, but also A and G are going to be the same. Now, why alternate? That means that they are on different sides of what the transversal is, this line over here. So one is on the left, one is on the right, and why exterior? Because they're outside this sort of interior area section here. They're on the outsides. So our alternate exterior are going to be the same, but also our alternate interior. So this time they're going to be inside this little area here, and on different sides of our transversal. So C and E are going to be the same, and also B and H. And for the last couple here, that you would know why they're equal, they're going to be vertical angles. So B and D are going to be the same because they're vertical to each other, which means that they're, I guess, on opposite sides of the intersecting lines, for example. So D and B would be the same, G and E would be the same, C and A would be the same, H and F would be the same. They're opposite to each other here. So that's sort of all you really need to know for how the parallel line system works for this test. And it's very important for you to figure out similar triangles. So similar triangles are going to be triangles that have the same exact angles, and triangles that have that share the same angle measurements are going to have corresponding sides be proportional by the same factor. So what that means is if BD to BA here is, let's say, 2 to 3, then that means that BE to BC, no matter what their side measurements are also going to be 2 to 3. So let's say, for example, that BE measured 4, then BC has to measure 6, so that we keep this ratio here of 2/3. Why is that? Because 4 over 6 simplifies to 2 over 3. These are equivalent to each other. And it's also going to hold true for something like DE here. Again, if we're keeping 2/3, let's say DE is, I don't know, I'm just going to pick a random number here. Let's say this one is 4, and then this one will be, is that the same one I just did? Well, the ratio will remain the same for all corresponding sides. And this holds true even if the triangle here is not inscribed into a larger triangle, but this is generally what the I guess shape looks like. Now, how do we know that all their angles are the same? They're usually going to tell you that the bases are parallel. So DE would be parallel to AC here, and then we know from our parallel line system that they're going to have the same angle measurements because this alternate exterior here, angle C, and the angle that will be vertical to angle C here are the same. So then angle C will also be the same as angle C. The parallel line system lets us know that they are sharing the same angles at the edges. So angle E will equal angle C, angle D will equal angle A in quite the same way, and they already share angle B. So they have all the same angle measurements, and then you know that their side lengths, their corresponding sides are going to be proportional to each other by the same factor. All right, and that leads us to our just important triangle formulas in general. We know that equilateral triangles are triangles that have all the same side lengths. You need to know also that they share the same angle measurement, that each of their angles is 60 degrees, all three of them. Isosceles triangles that have two of the side lengths be the same also have the base angles equal each other. And we know the Pythagorean theorem maybe, but another very important way of figuring out the missing side lengths for this test specifically is the Pythagorean triple. You don't necessarily need to use the Pythagorean theorem at all, actually, if you remember just two of our Pythagorean triples here, 3, 4, 5, and 5, 12, 13. So this might save you a lot of time. if they give you any right triangle and they tell you that the um, hypotenuse here is 13, then and that one of the other sides to say is 12, then you know that the missing side is 5. Actually, I guess this one's longer than that one. These would have been switched around. But that's the general idea. If you know any two of these, you also know the last one, and you don't need to plug into the Pythagorean theorem formula at all. Also, check out how 6, 8, 10 is just 3, 4, 5 multiplied by 2. This is a common one, but you don't really need to memorize it. If you see any version of these multiplied by any number, so long as it's the same factor multiplied by each of the terms of, I guess, this Pythagorean triple system here, then that is also going to hold true. Great. And then we should also remember that all the angles inside a triangle added up together are going to form 180 degrees. And keep in mind our special right triangles. For any isosceles right triangle, we know that the hypotenuse will be the measurement of one of the legs. So here in this case is x times square root of 2, so x root 2, or root 2 times x in this case. Or for any triangle that has the angles in the ratio 30, 60, 90, you know that the longer leg will be the square root of 3 times the shorter leg, and that the hypotenuse will be twice that amount. Now, when do you ever actually come in contact with this in these problems? Sometimes they do give you one of these triangles and they tell you the angle measurements, and you know it's a 45, 45, 90 or 30, 60, 90. But more often than not, you actually have to figure this out. For the 45, 45, 90s, this usually comes from a square, where you have to, I guess, divide it into two equal triangles. And then, or maybe the square is already divided for you, and then you have to figure out certain things about the square by realizing that, well, since it's a square, all the sides measure the same. We basically have two isosceles triangles here, and they're both right isosceles triangles, so they must be 45, 45, 90s. These angles here are all going to measure the same, which means that if you know, maybe say the side length of one of the sides of the square, then you know that this line here in the middle will have to be root 2 times that number, times x. Now, for the 30, 60, 90s, these usually come from equilateral triangles, where you already know that they have 60 degrees here in the bases and 60 degrees here up top, but you're going to divide this particular equilateral triangle in two. So you end up with two very different triangles, but because we divided this 60 degrees here into two parts, they're each going to be 30, 60, 90 triangles. 90 because we divided into, we ended up with our right angle here at the bottom. And then you can know things about this equilateral triangle overall from these smaller, I guess, 30, 60, 90 triangles that you got from within it. So that's generally how these are going to come into play. The following are some important function formulas to remember for the math test. We begin with the point slope formula, which allows you to find the slope of a line, here represented by the letter m, by plugging in the y values and the x values of 2 points on that line. You can think of this usually applying to a problem where you're given a graph of a line on the coordinate plane and they give you 2 points along this line. You can plug in those points into this formula. So the x value of one of the points, it doesn't really matter which you pick, going first over here, the x value of another one of the points, going into this one, and then making sure that the corresponding y values go into the order here, keeping the 2 and the 1 in mind. Another one here is the slope-intercept form, and this one allows you to find much more than just one thing here. You can figure out, for example, given the slope and what the y value is, you can figure out what the y-intercept of a line is. So what matters here is b gives you the y-intercept of a line, m is going to give you the slope, and x and y stand for the x and the y values anywhere along the line under consideration. The midpoint formula, also about lines, is going to be the point in the middle, the midpoint in between 2 points of a line. So say you're considering point 1 over here and point, whoops, that does not look like a 1. Let's say we've got point 1 over here and point 2 over here, the midpoint is going to lie somewhere over here. You look at the x and the y values at points 1 and point 2 and use those to figure out what the midpoint of the line will be by plugging into this formula here. And finally, the distance formula. So this one is going to give you the distance between 2 points, which can always be very hard. Again, just plugging in x values and y values, the corresponding ones. So all of these have to do with the lines. But what about some formulas that can help you do better on the rest of the exam, things that don't necessarily have to do with lines? Well, formulas in and of themselves might not be the most useful thing here, but there are two different question types that we can look at in a little bit more depth: systems of equations and just regular quadratic equations we can manipulate here. And we can look at these in a little bit more detail in this slide. So for systems of equations, you're going to be given two equations or more. Here we've got an example with two specifically, and they're going to ask you to use, or I guess require you to use, either elimination or substitution to figure out the value of one of the terms. Here we're looking for the value of y. Now let's go ahead and use substitution for this example first, and we can use elimination later. We don't want to substitute this value here for 2y into the second equation. If we were to do that, we would lose our y value. We would have it now in terms of x and z, and we wouldn't be able to figure out what y is. But we can solve for another value. Let's go ahead and solve for z. We can subtract 2x from both sides here so that we would get z equals 2y minus 2x. And now that we have z equaling 2y minus 2x, we can substitute 2y minus 2x for the value of z in the second equation. So we get 2x plus 2y plus 2y minus 2x is going to equal 20. So let me go ahead and write the rest of the equation up here from the bottom, so we have it all on one line. Now that we have it looking like this, we can go ahead and add up the terms and solve for the missing values. So these two x's here are going to cancel out, because 2x minus 2x equals 0. And this 2y plus 2y will become 4y. So now 4y equals 20. And to solve for the value of y, we can divide both sides by, not by y, by 4. And we have that y equals 20 divided by 4, or 5. So using substitution here was very helpful. But how would we use elimination? What is elimination? Elimination is when you add or subtract equations one from another to try to cross out terms that may not be as useful. So we can have, for example, 2x plus 2y plus z equals 20, and then we can have the x's and the y's and the z's all lined up. So we can say 2x here, it's already there. We already have a z, so we can have plus z here again. But we can subtract 2y from both sides to get our minus 2y over here and set that equal to 0 since we subtract 2y from both sides. And now that it looks like this, we can subtract the bottom equation from the top equation, cross out the x's, cross out the z's, and we're left with 2y minus a negative 2y, or a positive 4y, equals 20 minus 0, or 20. Once again, 4y equals 20 is going to simplify to y equals 5, because 20 divided by 4 equals 5. Both methods work, and they're going to be useful for solving problems dealing with systems of equations. Now, the other question type here that will be really useful for you to work with are just equations that are requiring you to factor or to plug in from available answer choices. So a good example is the following. They're telling you here that x minus 2 squared equals 25, and that they want the value of x that is negative, the value of x that is less than 0. So what's the value of x we're looking for? Well, there's two ways to do this. You can look from among the answer choices to find a value such that you know this entire thing here is going to be the square root of the other side of the equal sign. So basically, you want a value for x that's going to give you x minus 2 equals the square root of 25, or 5, and you can solve for the missing value that way. Another way to do this is to factor out this problem here. You can use FOIL. You're going to get x squared. But actually, let's go ahead and use FOIL together all the way around. what do I mean by use FOIL if you've never heard of this expression before? FOIL means we're going to multiply the first term times the outer term times the inner term times the last term. All of these concepts will be covered in greater detail in a later lesson. But let's just go ahead and apply this. So the first terms multiplied by each other are going to give you x squared. The outer terms, negative 2 times x is negative 2x, so minus 2x. The inner terms, negative 2 times x, so once again, this is minus 2x. And then the outer terms, negative 2 times negative 2, will give you a positive 4. So basically we have x squared minus 4x plus 4. I'm going to go ahead and write that again. X squared minus 4x plus 4. And that equals 25. So one thing we can do is subtract 25 from both sides. And then we end up with x squared minus 4x minus 21. And we can go ahead and factor this such that we get two numbers here that added together give you negative 4x multiplied together give you, or negative 4 and multiplied together give you negative 21. So I can think of negative 7 and plus 3, for example, where negative 7 times 3 gives you negative 21, and negative 7 plus 3 gives you negative 4. And this would give you two solutions. X equals negative 3 and positive 7, since negative 3 plus 3 gives you 0, and 7 minus 7 gives you 0. So we used an idea here where we looked at an answer choices, tried to plug in something that could give you 5 at the beginning, and then we used another idea here where we could just expand this, factor it out, subtract, and then figure out what the zeros of the equation would be to figure out answer choices for x. So if we got x equals negative 3 or 7, then we can say, okay, we are looking at the negative value, so the answer will be negative 3. Something else to keep in mind as you go through the algebra section of the ACT math test is that inequalities are going to work the exact same way as regular equation functions, except when you multiply or divide by a negative number, the inequality is going to flip. That means if you have x is less than 5, and then you multiply everything on here by negative 1, say, so you end up with negative x and negative 5, the inequality is going to change to that side. So now it's going to be negative x is greater than negative 5. The last difficult set of formulas here for the ACT math test are going to revolve around parabolas. Now, the original parabola formula is simply f of x equals x squared. Now, when you subtract or add to the operation here of f of x, the parabola is going to shift vertically. If you subtract 3, for example, its center at 0, 0 will go down to 1, negative 2, negative 3. It's going to be the exact same graph, except the center will now be at y equals negative 3 rather than y equals 0, but still at the exact same x value. If you were to add, let's say we were going to add 1, x squared plus 1, the center would now be at 1, and the parabola would look the exact same thing, the same way as before, just it would just be higher on the y-axis by 1. Now, when you are adding within the parentheses, so you're going to have x plus something, and then that's going to be squared, that's going to shift it to the left or to the right. So it's going to be the opposite of the value here. So if it's a plus, it's going to shift to the left or in a negative direction. So here we've got x plus 3. The center is now at negative 3. If it was a minus 3, the center would be now at a positive 3 here on the other side. We also have this strange here notation that's telling us about dividing x by a number. If you divide by a specific number, this x squared, that's going to change the width of the entire parabola. What I recommend you do is that you plug in from the answer choices to see how that affects any numbers that you may already know of. And so we reach some trig formulas here. Now, if you've never seen trigonometry before, don't let this scare you. We will discuss this in a lot more detail in a later lesson. But if you've seen it before, be rest assured that we're only going to be looking at your basic trig identities, so knowing that the inverse of sine is the cosecant, cosine is the secant, tangent is a cotangent, and you need to remember that tangent equals sine over cosine. Well, we're looking at these. We're also looking at SOHCAHTOA. So to remember that sine is going to be the opposite over the hypotenuse, or cosine the adjacent over the hypotenuse, etc., etc. If you've never seen this before, if you forget, remember that these are split, where O stands for opposite and H for hypotenuse, and A stands for adjacent, and then S stands for sine, C for cosine, and T for tangent. And then also this one Pythagorean identity, the only one, that sine squared of theta plus cosine squared of theta equals 1. Often they ask for this directly. And then also they will provide you with this formula, the law of sines and cosines, and you will have to apply it. Now, the one thing that is a little bit different that's not on here are the trig function graphs. Now, we've never seen any questions dealing with tangent, but tons dealing with sine and with cosine. And basically what you need to know is when you multiply either sine or cosine by a number, so if you see 3 sine, for example, or 2 cosine, that's going to change the amplitude. Now, the amplitude of these graphs usually goes from -1 to 1 in both cases. But when they're multiplied by any number a here before, that is going to be the new amplitude. So if it's multiplied by 3 here, the sine graph will be -3 to 3. Or this cosine by 2, -2 to 2 now. Another thing is the multiplication of anything within the parentheses here is going to make it so that the period is going to be divided by that number. So the period is generally from 0 to 2 pi here for both of them, where sine goes through the x-axis at pi, and cosine in between 0 and pi, so pi over 2, and then in between pi and 2 pi, so 3 pi over 2. Now, what happens if you put a 2x here in between the sine? These values will simply be divided by 2. So instead of sine crossing the x-axis at pi, it now crosses it at pi over 2. If you put a 3 in between the cosine here, instead of cosine reaching -1 at pi, it will now reach it at pi over 3. You're simply dividing by the period by the number that's being multiplied by x here. And of course, last but not least are our data formulas. So for these, you need to know that mean is going to be the same as average. And to calculate the average, you're going to figure out what the sum of a series of numbers is, and then divide by the number of add-ins, so the number of numbers, I guess, that you added up here together. So there's 7 numbers here, all added up together. So we're dividing them by 7 because there's 7 of them, and that would give us our average, or our mean. The median is going to be the 1 or ones in the middle. Usually there's only one number, but if there's more than one, you're going to want to take the average of the 2 in the middle. So 4 plus 4 divided by 2 here gives you 4. And then the mode is going to be the one that happens most often. So here 4 occurs more often than any other number. There's two 4s, whereas there's 1, 1, 2, 3, etc., etc. So we know that is the mode. And our last formula for today, and our little refresher of math formulas for the ACT, is for probability. Usually the chances that anything will happen are going to be the number of equally possible desired outcomes, so what you want. Say you have 5 different I guess pieces of candy that you could eat, and you want 3 of them. You only like 3 of the 5 that are available to you. You would have the total number in the denominator. So you would have 5 in the denominator and the ones that you want in the numerator, and that would give you the chances of you getting one of the candies that you would enjoy. The desired outcomes on top, the total possible number of outcomes, or I guess equally possible number of outcomes in the denominator.